This video is about how to find holes in rational functions. If you need a little bit slower explanation of kind of the theory behind it, I did another video. It's called Rational Function Holes. But this one's going to be a quicker example, just so you can see the idea here. So there's two different schools of thought here. As a rule, a lot of people are like, well, I'm just going to go ahead and factor both the numerator and denominator right now, so it helps me later, because eventually I need to solve the numerator for the x-intercept, and eventually I need to solve the denominator for vertical asymptote. So a lot of people are like, well, we'll just factor it right now. And actually, that's a good rule of thumb, because we're eventually going to have to solve them anyway. So let's go ahead and factor the top here. I'll do the work actually down here. So x squared minus 3x plus 2 equals 0. Let's see if we can x factor that. 2 up on top, negative 3 on the bottom, negative 2, negative 1. Gives me that combination. A is positive 1, perfect. So I can write it as x minus 2, x minus 1. Cool. On the bottom, it's a difference of two squares. So that means I can just write x plus 1, x minus 1. And notice how I do have a term that matches on both the top and the bottom, so I can cancel it out. So that's going to be where a hole is. So when I write down my data, let's just go and say a hole at x equals 1. Okay. Now let's find x-intercepts, which see how you factor in it. If there's a hole, it makes it a lot easier because we just solve each piece here. And I'll go ahead and write all the answers here. So x minus 2, that's going to be x equals 2. So that's where my x-intercept is, 2. Y-intercept, again, we can just use the remaining equation here, because that, even though we take out the hole, it does not affect what the data is going to be. So we plug in 0 for x, that's going to be negative 2, because it's negative 2 over 1. For vertical asymptote, again, because we took out the hole, we only need to solve that bottom piece there, so x equals negative 1. Cool. And then horizontal asymptote, the powers of the exponents match both on top and bottom. So we just take the coefficients, 1 over 1, which is just 1. Okay. So if I graph this, x-intercept at 2, y-intercept at negative 2, vertical asymptote at negative 1, and a horizontal asymptote at 1. All right, and using my x-intercept and vertical asymptote data, so it's going to be 2 and then negative 1. The function starts off positive. At 2, where I got that answer, it's an exponent of 1, so switch. And then negative 1, it switches again, because it's an exponent of 1 or multiplicity of 1. So, again, notice how I'm going to be below the asymptote here, then it crosses 2, negative 2. So, but notice at 2, it goes from positive to negative, so I'm going to stay negative here. Then at negative 2, it's all positive. So that means it's going to be up here in this part of the graph. All right? And that is how you would graph this rational function. So, oh wait, and of course the hole, which is at 1, I always forget that. So notice how wherever the graph is at 1, so I'm going to go ahead and put a open circle here, because the graph can cross through it, but it can exist everywhere else except that hole, which is at 1. Okay, so that's how that graph works. All right, and that is how you do rational functions with holes.